In the previous video, we've seen how we may find the dual of a normal maximization problem. Now let's do the same thing, but for normal minimization problem. Okay, so we are given an example of a normal minimization problem. Again, it is normal because for minimization, the sign of the constraint is greater than or equal to, and the sign restrictions for all variables is greater than or equals to 0. So this is a normal minimization problem. Let's look at this table, and I will cover the maximization part because it will be what we are doing to find the dual. Okay, so as usual, let's fill this information into the table. So given the primal is a minimization, now we start from here, minimization, and then we write down our variables y1, y2, y3, y4 as the rows here. So for minimization, you always do this. And then you put the sign restrictions here, y1, y2, y3, y4. They're all greater than or equals to 0. And then now when you would like to write down the constraints, you need to write the constraints down for each column. Okay, so 400 times y1 plus 200 times y2, 150 times y3 plus 500 times y4 greater than or equals to 500. Okay, so for minimization, this is always how you read the table. So that's the second constraint, this is the third constraint, this is the fourth constraint. And then you write down the coefficients of y1, y2 up to y4 in the objective function on the right hand side here, 50, 20, 30, and 80. So that's how you put all the information from the given primal minimization into the table. So always read the table down for minimization problem. Okay, so now let's fill the table with the information that we need to find the dual. The primal is a minimization problem, so the dual is a maximization problem. So you write max C. And then for each column, we write down the primal variable. Sorry, the dual variable in the maximization is x1, x2, x3, and x4. You can see that each variable in the dual problem corresponds to one constraint in our primal problem. So one constraint in primal corresponds to one variable in the dual. In this case, our primal is minimization, our dual is maximization. Now the third thing is put the sign restrictions. The sign restriction for each variable may be inferred from the constraints in our primal. So our primal is minimization, and the normal constraint in minimization is greater than or equal to. That's why the resulting variable in the dual, they are also normal. Normal variable in maximization is greater than or equals to 0. So that's why x1 up to x4, they are all greater than or equals to 0. Again, because they come from normal constraint in our primal. And then for the sign of the dual constraints, we need to look at the variable where it comes from. So the variable y1 will result in, see here, the variable y1 will result in a constraint in the dual. The variable y2 will result in the second constraint in the dual. So the variable y1 is a normal variable in our primal. Our primal is minimization, and the sign restriction of greater than or equals to is normal. So our constraint in the dual is also normal. A normal constraint in the maximization problem is less than or equal to. Because all variable in our primal is normal, that's why our dual constraints, they are all normal. Now we can read the table across to obtain the dual. So our dual problem is a maximization case, and then read the rows to obtain the constraints. So 400 x1 plus 3x2 plus 2x3 plus 2x4 less than or equals to 50. Do the same thing for all constraints. Sign restrictions is straightforward. Now for the objective function, this is how you read it. 500 times x1. Ignore this sign in the in the primal constraint. So ignore these signs and then just read it. 500 times x1, 6 times x2, 10 times x3 plus 8 times x4. Okay, so we have obtained the dual problem, which is a maximization, the dual problem of the given primal problem. Now here's a question to check your understanding. If a primal LP is a normal maximization problem with 7 variables and 5 constraints, then the dual LP is a normal minimization problem with 7 constraints, the sign of all constraints is greater than or equal to 5 variables, and the sign restrictions of all variables is less than or equals to 0. Is this statement true or false? I will give you a pause on this video to give you the time to read the question carefully and think about the answer. I will give you the answer after the pause on the video. The answer is false. Let's see where the statement goes wrong. Primal LP is a normal maximization, so dual LP is a normal minimization. Up to here, it is correct. 7 variables in the primal will become 7 constraints in the dual. This is correct. 5 constraints in the primal will become 5 variables in the dual. So up to here, everything is correct. The sign the sign of all constraints is greater than or equal to. Well, because the primal is a normal maximization, so we know that all variables, they are all normal. In the maximization case, is greater than or equals to 0. So in the minimization, the dual, the sign of the constraints, they are all also normal, greater than or equal to. Now, this is where the statement goes wrong. Because the primal is a normal maximization, so all constraints, they are all normal, which has the sign of less than or equal to in the maximization. Normal constraint will result in normal variables in the dual. The sign restriction of normal variables must be greater than or equals to 0, and it applies whether it is a maximization or minimization case. The sign restriction of a normal variable is always greater than or equals to 0. So this is where the statement goes wrong. Okay, so that's the end of this video, and see you on the next one. Thank you.